video, I'll show the work that we did to find our x-intercepts and y-intercepts. And we're going to go to page 355. And we know how to graph y equals 2x plus 6. But now we're going to learn how we graph inequalities. So right beside these, I would like you to show the following. If you have a y greater than, what's going to happen is you are going to draw your graph and a little note here. If you're graphing an inequality y greater than 2x plus 6, I'm going to graph 2x plus 6, but I'm going to graph that line with a dotted line because it's just greater than and not equal to. If we have an equal sign, we'll graph a solid line. If we have just the greater than sign, we're going to graph a dotted line. Okay? If it's greater than, we are going to shade above, because if you take any point on this line, let's say I take, for example, the y-intercept 0, 6. Obviously, 0, 6 doesn't work, because if I plug it in, those two things are equal. I need the y values to be bigger than the graph. But if I tested 0, 8, it makes the equation true. If I plug in 0 for x, the right-hand side is 6. If I plug in y as 8, is 8 bigger than 6? True. And so with linear inequalities, we're wanting to shade all of the area of the graph that's true. Anything that's above the line, the y values will be bigger than the line. And if we want y greater than, that's what it's asking. Where are my y values bigger than that line? Every single point above that line would make it true. Like I could do another test point right here. Let's go to -4, -4, 6. If I plugged in 6 for y and -4 for x, is it true that 6 is bigger than -2? Absolutely. So the shaded part shades every single point that makes it true. And there's a lot of them. The unshaded part shows every single point that wouldn't make it true. Like if I tried here, this green point, 2, 0. If I plug in 0, I have a question mark here. 0 for y and 2 for x. Is 0 greater than 10? False. And that's why that point is not in the shaded region. So in graphing inequalities, we graph the line like normal, but sometimes it's dotted and sometimes it's solid. Okay, we're going to, for y greater than and y less than, they'll both be dotted. We use a dotted line when the line is not included. But for y greater than or equal to, here we'll still shade above, but now we're going to have a solid line. And for y less than or equal to, we will still shade below, but now have a solid line. So how do we graph linear inequalities? Well, we start by graphing the line like we would normal. So if you were asked to graph y is less than or equal to 2x plus 6, you would start with a 2x plus 6. You would say, I know that 2x plus 6 has a y-intercept of 6 and a slope of 2, which means I can go over 1, up 2, over 1, up 2, or down 2, over 1. And it has a positive slope, so I know from my y equals mx plus b that my line goes up from left to right. So all of that review from grade 10, graphing lines, comes back in this part. I will make my line solid if I have an equal sign. And I'll make my line dotted if I don't have that equal sign. Then I need to decide if I'm going to shade above or below. Okay? I like doing this idea. Like here it says the y values have to be less than the line. If my y values are less, do you see that that would be going down from the line? That shades everything below the line. But the other thing that sometimes people do is they take a point, and a favorite point to choose is 0, 0. If you choose the point 0, 0, and I plug it in, is 0 less than or equal to, question mark, 2 times 0 plus 6. In other words, is 0 less than or equal to 6? True. If you find a point is true, every point in that section will be true. Sometimes I say test 2 points, because if you make a mental math error with the one that you test, and you get it wrong, you will get them all wrong as a result. But if you test 2 points in a section, and they both come out true, you can probably be like, what are the chances I made 2 mental math mistakes? Don't ask.
Pretty good, actually.
Pretty good, right? Some of us better than others. So maybe you want to test 3. Okay? Or maybe you do a test point and you use this idea that y values less than or equal would be below. Y values greater than or equal to would be above. And these are called linear equalities with 2 variables. They're called linear because you draw a line. What do you think we're going to do in 5.3? We're going to do the same thing with parabolas. So today reviews graphing lines. Tomorrow we'll review graphing parabolas. So let's go to example 1. You want to graph the inequality x minus 3y is greater than 6. So first a little review. You probably used y equals mx plus b a lot for graphing lines. Okay? So you could either use the y-intercept and the slope, or any nice point and the slope. Sometimes you could just find 2 points. If you find 2 points, you can draw a straight line through them really easily. So these are options. Find a slope in 1 point, find 2 points, find both your x-intercept and y-intercept, and you can draw a line straight through them. These are great review things of how to graph our lines. A little review of inequalities. There's one special rule for solving equations with inequalities. Do you remember the special rule?
Yeah.
What is it?
When you multiply or divide by a negative number, you have to flip it.
Yes. So it's just for multiplying or dividing. You flip the inequality. So this is a little review stuff before we even get into this question. And why does that become important? Well, in this question, let's say I want to use y equals mx plus b. I'm going to have to rearrange this equation, right? How am I going to do that? I can move the x over by subtracting x. Subtracting doesn't flip the sign. But then if I wanted to get y by itself, I would have to divide by a negative 3, which flips the sign. Dividing by a negative 3, that will make this 1/3 x. Dividing by a negative 3, this will make this negative 2. So from here, if I wanted to graph that line, it is in y equals mx plus b form. I would know that the y-intercept is at 0, negative 2. I could use my slope to find another point. How? Well, I could go up 1 over 3, right? This was up 1 over 3, because your slope is your rise over run. And it has to go up 1 over 3 in that direction because my slope is positive. And from that, I could label a second point, which is going to be 3, negative 1. And once you have 2 points, that is enough to draw a line through them. Should I draw a dotted line or a solid line?
Dotted.
Dotted. Do you know what? You know what happens to me so many times? I'm so used to just drawing graphs. I draw a straight line and go, oh, crap. I actually have my dotted line drawing strategy usually involves an eraser. Because I draw the solid line and then I'm like, oh, I was supposed to make it dotted. And then I take out my eraser and erase to make it a dotted line. So here is, make it more dashed. It's too dotted for me. There we go. There's my dotted line. Now finally, I have to shade. Will I shade above or will I shade below? Okay. You could take 0, 0 as a test point. If you plug in 0 for y and 0 for x, is 0 less than negative 2?
No.
No. 0, 0 would show up as false. Okay? For shading, I like to use crayons because it's a good excuse to use crayons. And the crayon option on the smartboard is really nice. So, what color are you feeling?
Yellow.
Yellow. Okay. So that. No, I don't like yellow. Sorry. It's not very. It's too highlighted. Oh yeah. There we go. I'm going to shade in my crayon. As a nice result. So we draw our line, make it dotted or solid. We use our skills at graphing y equals mx plus b to draw that line. Okay? Or you could use your intercepts, because sometimes your y-intercept isn't a nice point, so you might want to use something else. Or you might just find a random point and use your slope. Then we shade either above or below. We can use a test point, or we can say if the y values are less than the line, that's below. Circle questions 3, 4, 5, and 7.